Great. I hope you all dedicate some time to watch the last video, and I will start to share my screen now. Um, Great.
Are you referring to Prof?
Great. Perfect. Perfect.
Uh, Sorry, Prof. You said you were going to do a recording. I don't know. Is it? Are you referring to that one? Because we didn't. I didn't send recording.
Uh, to me, it's showing that's recording now. Can
No, no,
someone?
no, no. You know, last week you said you were going to do a recorded class.
Uh-huh. Yeah. But it's on the. Let me show you where you can find it.
Is it on the drive?
Yes, in the drive.
Oh,
Let me show you.
I kept looking for. I didn't even. I didn't even occur to me to check that. I didn't see it. Yeah.
Okay.
I'm
But
not sure many of us remember to go there. It's okay. I was
okay.
expecting a mail or something. I didn't know that you sent it to the Google Drive. I'll check it.
Oh, I send it. Yes, it's here in the seventh class. Okay.
I can see. Okay, no
So
problem.
you just need
I'll,
to access the folder and links. It's here. Okay. And guys, thank you very much. I saw that a lot of people already send the activity about the diagnostic horizons. I didn't have time enough to check the answers, but don't worry about it, okay? Because it's just a training. Let's do an exam in the next few weeks. I will let you know after we finish the cell taxonomy, so then we can schedule an exam, and basically the exam will be the same that of this training exercise. I will just provide some information, some morphological information, physical and chemical, and I will ask you, please classify the pattern according to soil taxonomy. Please classify the subsurface diagnostic horizon according to soil taxonomy. And then I will ask, please classify at level of order according to soil taxonomy. Okay, so it's why I'm waiting that we finish the soil taxonomy before the first exam. Okay, and of course, I also will give you some time to do that, like 1 week. I can just provide the data and I will ask you in 1 week to answer the questions. Probably around 4 or 5 questions, because I will try to explore all the knowledge and all the app patterns and all, or at least the majority of the diagnostic horizons, of course, because they are a lot. But I will try to do that, and I will let you know at least 1 week before, so you can plan, okay, this week will be great because I need to put more effort doing that. Again, all the material, all the references and books and the videos that you need, they are in our folder, so you can access the folder when you want to do that. And always, if you have any doubt, just let me know. Okay, you can stop the class and ask, or you can just email me, or we can talk, we can schedule a specific meeting, and I can help you with any doubts. Okay? So let's start. I will start to share. Okay. Oh, great. So in our last class, we finished our class before the aridisols. And the aridisols, they are soils, as the name says, soils related to a very dry climate condition. Okay, so they are really common in arid conditions. In some arid environments they can be found too, but we can find them more related to very dry areas when we have some torric and acidic moisture regimes. Because of the very high temperature, we have very low water liquid water content available, and this affects a lot of soil properties. This affects a lot of soil process. So the migration of clay or the wafting of materials, they are deeply affected by this availability of water. Of course, we can see some salt concentrations, carbonate concentrations, and several processes that are connected to this very low water availability. And of course, this very high evapotranspiration also induce some specific process. But let's talk about this. I will close. I just let me close the door. Just leave this on. It's just great. Now you close. The door it's opening and closing. So first of all, the radisols, they are basically connected to a concept that we call soil moisture regime. I don't pay a lot of attention in our course to this topic because let's say that it's quite basic. Okay, soil moisture regime, it's related to the availability of water in the soil. And in this case, the radisols, they are connected to the aeritic or toric regimes that are regimes, soil moisture regimes that express a very low availability of water. Okay, so in this case, for the radisols, the soils, they should be moisty or wet in less than 90 consecutive days. So you cannot consider that this soil has a lot of water, okay, because the soil has water or moist conditions or wet conditions in less than 90 days, 90 days, 90 consecutive days, okay? So at least 1/3 of the year, the soil has very dry conditions or the soil is totally dry, okay? And the temperatures will be equal or higher than 5 Celsius degree. So you have a dry condition associated with high temperatures. Okay, so this dry condition is not related, for example, to polar conditions, to very cold regions like Antarctica, but they are quite dry because in this specific area, you have a very hot area. So the availability of water it's quite low because basically all water or almost all water it's evaporated. Okay, so the concept that defines this is, as I said, the soil moisture regime of aeritic or toric that express a very low water availability during the year. Okay, these soils, they express also a high amount of coarse materials. These coarse materials, they express a high content of rock fragments and gravels. And it's quite easy to understand why, because if I don't have a lot of water, especially the content of water, the liquid water is just available for some days, the chemical wafting is not quite intense. So because of this, the production of clay, silt, and fine particles, they are not quite intense. The wafting is not quite intense. So it's quite common that these soils, the radisols, they are quite rich in coarse fragments, in rock fragments, in gravels, and other kind of particles, okay? And we know that these coarse materials, they don't present a very high specific surface because the surface is quite high and they are quite heavy. So because of this very low specific surface, they cannot absorb a lot of water. And then any kind of water that can fall in this area because of the precipitation will just penetrate through the soil and can achieve the water table level. And at the same time, this water can just migrate horizontally to another area, or it can just evaporate, okay? Because we cannot form soils with a high content of fine particles, it's quite common that we cannot absorb or contain a lot of water, okay? And of course, we don't have a lot of water, but also we don't have a lot of organic carbon content. So it's quite common that some of the soils, they are virtually absent in carbon, especially organic carbon, because we don't have a lot of water, so we don't have a lot of biological activity. So the organic carbon content will be very low because we don't have addition of organic carbon by the biological process. So the organic carbon content could be very low. Carbon and organic carbon we can find, especially as carbonates. Okay, they can be found there because of this very high evaporation. So carbonates can be found in the soils, especially at the surface. But in organic carbon could be very, very low. Okay, and sometimes, as I said, the content could be not be measured because they are quite low. Um, of course, these soils, especially in semi-arid regions, they suffer a lot uh, because of the runoff and wind erosion. Okay, so because the soils, they have a very high content of gravels and they cannot absorb a lot of water and they cannot host high contents of organic carbon. In general, the vegetation cover it's quite open. So you have a lot of soil that is exposed to the runoff and the rainfall, I'm sorry. And this rainfall, when achieved the soil surface, some water, of course, can penetrate through the soil, but the majority of this water will just run as runoff, will run at the surface of the soil and will induce a strong erosion, okay? This runoff could remove a lot of fine particles, especially the clay, and can reduce the clay content at the surface, okay? So the runoff, of course, because you have a lot of soil that is exposed to the surface and the rainfall achieves the soil surface without any kind of vegetation cover that could reduce the velocity of the water drops or could reduce the velocity of the water at the surface. And because of this very high surface water in the surface, so you can remove some clay and reduce the clay content. We will talk about this in the next few slides because this could be connected to some diagnostic horizons that we can see. Okay, so this runoff is produced because we don't have a soil that's protected by vegetation cover. Okay, and the wind erosion, it's also quite intense in these areas, and the wind has an erosion strongness that it's quite selective. So the wind can easily remove clay and silt in some cases, but hardly can remove a lot of sand and even gravel particles. So when you have an area that's affected by strong winds, these winds, they will reducing the content of the clay in the surface, in the apaton. And because of this, we will see we can register in some cases some diagnostic horizons that are connected to this difference of texture, to this difference of clay content between the apaton and the subsurface horizons. But let's talk about this in the next few slides, okay? And also, it's quite common to see in some areas some desert pavement. This kind of pavement, it's more related to this strong erosion by the wind or by the water in the case of the runoff, and there's intense removal of clay particles. So you relatively increase the content of gravels, sand, and coarse particles at the apaton or at the surface, and you reduce the clay content at the surface. So you create a surface that has a lot of gravels, and because of this, we call it as a desert pavement. Okay, let's just check. Oh, something that's quite common also in, especially at apaton, is to see this kind of voids. You can see this vesicular voids that they are quite common at the apaton, at the surface horizons, because of the rainfall achieving the surface of the soil, it's quite common because it's strong. How strong is these water drops? They could create a sealed surface. They could create a high density surface layer that it's related to the broken of these aggregates. You are just achieving the surface, you are just achieving the pads or the aggregates, and because of this, you destroy them. And then the particles can be removed or they can reorganize it. And you can organize a layer that has a high density, and sometimes even the roots cannot grow very easily, and you can see this kind of voids because of this intense process of destroying of aggregates. You are destroying aggregates and you create this high density layer. In this high density layer, you can register this kind of vesicular voids because the water is kind of lucky inside this seal layer, and the water cannot easily migrate, but you have some oxygen in the water, and because of this you create this kind of bubbles. And when the water is completely evaporated, only air is inside the bubbles, you create this kind of form. Okay, so it's quite common to see in aerosols. It's quite common to see this kind of feature in soils that are quite dry, that register aeric or torrec regimes, because they are connected to this high exposure of soil in areas that are quite open-end, okay, and torrential events. This is the desert pavement that you can see, so a high content of gravels at the surface, and they just appears because you removed the clay. So you have an intense clay removal, and because of this, now you can see a lot of gravels. So you have a relative increase of gravels content. Okay, it's not an absolute. They are not eroded from one region and now they are concentrated here. No, they are red was here, but now you can see them very easily because the other particles, especially the clay that's quite light, was removed by the runoff and or the wind erosion. Okay, this kind of feature it's quite common in dry areas, in dry lands, in areas that you can find the aerosols. As I said, it's formed by the wind erosion and or runoff. Okay, and because of the very low water availability, you can register a low buffering and a low leaching. Okay, so it's quite common to find aerosols with a very high CEC, to find aerosols with a very high content of primary minerals as olivine, pyroxene, feldspars, and others. So the content of these primary minerals will be quite high. And as I said, even in some cases, you can find very easily weatherable minerals that hardly you can find in other areas, as for example gypsum. Okay, because of this very dry conditions. These soils, they also are affected by a high evapotranspiration. As I said, they are connected to aeric or torrec regimes, and because of this very low water availability content, they will register a high evapotranspiration also because of the high temperatures. And then this very high evapotranspiration could induce precipitation of salts and carbonates. In this picture, you can see here, especially here, some white dots. These white dots, they are salt precipitations, okay? So you already know how to distinguish between carbonates and salt at the surface. You just need to drop some acid. If you see some bubbles, okay, this is carbonates. If you don't see bubbles, this is salts. So you can distinguish between them at the surface, just dropping some acid, but both are common. And in sometimes you can find both in the same horizon. Okay, so as I said, the best technique to identify these minerals is the XRD. So you need to take a sample, send to the lab, and then identify correctly which minerals you can find in the soil. But they all are showing you that, guys, this soil is affected by a very, very dry condition. Okay, so just to consider that you are standing maybe on a reedy soil. Okay, or at least a soil with a very dry conditions. This photo you can see a little bit better. These white dots, so you can see that a lot of these white dots, they are formed in the walls of the soil profile, showing that they are connected to a very dry condition, very high evapotranspiration, inducing salt precipitation. So, okay, let's see now the required criteria to identify a soil as already dissolved. Okay, so first of all, we need to consider that to be an aridisol, this soil could not fulfill all the criteria to the other orders. Okay, so you need to remember, oh, we have the jelly salts, we have the isosols, we have the spotosols, we have the oxysols, we have all others. So this specific soil that you are standing in the field, you cannot fulfill the criteria for the others. Okay, because if you fulfill the criteria for any of these other orders, any of these other groups of soils, so that specific soil should be classified as one of those soils. Okay, if the soil that you are standing in the field, that you are checking, if you are analyzing, you cannot classify as any of these orders. So, okay, let's give the aridisols a chance. So maybe it could be an aridisol. And then we just need to check the criteria. I like to memorize, to highlight this because you need to memorize that. Okay, sometimes people, they do misclassification because they forget about this, because we have some orders that they have some prevalence. We need to follow that order that I showed you in one of those first classes. You need to follow that order always, and you don't need to memorize it because we have it in soil taxonomy, so you can consult, you can check at the field, but we need to follow it. Okay, so again, let's return the required criteria for the aridisols. First of all, have an acidic soil moisture regime. So you need to find conditions that are quite dry. And to be honest, this is quite difficult for the majority of the world, for the majority of the researchers. Why, JJ? Because in the majority of cases, we don't measure the soil moisture regime along 1 year or even more than that. Because for doing that, you need to monitor the soil moisture in the soil. So you need to install some equipment and monitor each day the soil moisture. And to be honest, I hardly find people that do that. Why? Because it's hard, because it's expensive, because it's difficult, and sometimes it's even dangerous because you can install your equipments in the field and they can be stolen because you install something that's quite expensive in an area that no one's there, no one is watching, no one is looking after your equipments. Sometimes this kind of things happen, okay? And it's okay to occur this kind of things because they could occur. So a lot of researchers, they don't do that. So how can we identify the acidic soil moisture regime without soil data, JJ? We have some techniques that helps you, okay? First of all, on good XRD analysis, okay? Try to identify which minerals you have in the soil. Oh, I can find a soil with a lot of salts, a lot of carbonates. So they are showing you that a secondary carbonates, okay, guys? So you can see that in this case, these minerals, they are expressing a low water availability, showing you that they are precipitated and they are stable because you have a very low content of water. So this could be an evidence of an acidic soil moisture regime. So the presence of some minerals that are quite unstable in wet or at least less dry conditions, it's a very good tip to identify the acidic soil moisture regime. Also, the air temperature is quite good. So we have a correlation, especially in dry regions, between the air temperature and the soil temperature. So if you can access, you can find information about air temperature in an area, you can try to identify if that soil could fit the characteristics. Of course, the vegetation cover is also a very good information. So which kind of species can I identify in that area? They are species that are drought adapted species, species that can grow and survive in very dry conditions. Yes, great. So this is good. So we have some tips that you can use to identify the acidic soil moisture regime. But in my opinion, it feels like just tips. Still just a kick. Like, okay, I'm kicking that maybe it fits the acidic soil moisture regime. The only way to really know is install some sensors and monitor the soil moisture. And after 1 year, you have the information. It's why I don't like very much soil taxonomy. Let you know about this. I think that soil taxonomy has some issues, some problems. And for example, this is one of them. We cannot consider that to classify a soil, we need to wait 1 year to do that. It's quite strange, let's say in this word, okay? So you need to know the soil moisture regime to classify the soil. And to know the soil moisture regime, you need to monitor the soil for at least 1 year. And this is definitely not good, especially for poor countries, for example, as Brazil. As I said, hardly will find someone that monitors soil moisture regime in Brazil and can let you know that if that specific soil fits the acidic soil moisture regime. It's just some tips that we can find. It's just a kicking trying to fit this criteria. Okay, but you can see that it is a mandatory criteria. You need to fit this one, and you need to find an ocric or an anthropic pattern. So you should remember that the ocric pattern is that pattern that does not fit the criteria for the other patterns. So an ocric pattern does not register a very high content of organic carbon that fits very well to an acidic soil. And the thickness should be very, very thin, and the color could not be very strong or a strong dark color. You shouldn't register very high content of carbonate or calcium that's connected to a very high organic carbon content. You could not register a high content of clay that's connected to a very high content of organic carbon. So basically you found a pattern that is not too thin, is not too thick, and it does not register a very high content of organic carbon. Just that. It's a regular, is a typical pattern, okay? But especially typical from areas that register a very dry condition. Or you can register an anthropic pattern. And this anthropic pattern, it's connected to areas affected by humans, okay? So you'll have some areas that the pattern was changed by humans trying to improve the fertility, the chemical fertility, or trying to induce or increase the quality of soil to produce some kind of food, fibers, or anything else. So you can find the anthropic pattern in this case, okay? Because we have humans everywhere. So to identify a soil as an acidic soil, you need to find this acidic soil moisture regime, and you need to find an ocric or anthropic patterns, one of them. okay? And one or more of the following in the first 100 centimeters of the soil surface. You need to find a cambic horizon with a lower depth of 25 centimeters or more. So you need to find in the first 1 meter below the surface, you need to find a cambic horizon or a cryotic soil temperature regime and a cambic horizon, an anhydric, a calcic, gypsic, petrocalcic, petrogypsic, or salic horizons, okay? Or a duripan, okay? So all of these horizons, they are connected to dry conditions. Remember, anhydritic, you have the calcium sulfate, calcic, calcium carbonate, gypsic, the gypsum, petrocalcic, you have the cementation of a horizon or a layer by calcium carbonate. Petrogypsic, cementation of a layer or a horizon because of gypsum. Salic horizon, presence of salts. Or duripan, cementation by silica. So you have a lot of different horizons that are straight connected to very dry conditions, okay? And the cambic horizon, you also already know that this horizon, it's not very well developed. It's an incipient, weathering, incipient developing of horizons. So it's why we can find the cambic horizon too. And this, it's optional. You can find an argillic or natric horizons. The argillic horizon is quite common in the aerosols because of the runoff and the wind erosions. Okay, as I said, both reduce the content of clay in the apaton at the surface and the topsoil. So this reduction of clay at the surface could create a huge or at least a high variance or variability of content between the surface and subsurface horizons. So because of this removal of clay at the surface, you can create a high difference of clay content between the subsurface and the surface horizon. And this could produce an argillic or natric horizons. In both cases, you register a high difference of clay content between surface and subsurface horizons. And in the case of the natric horizon, you register also a very high content of salts or sodium, especially sodium, because of these very dry conditions. So it's quite common to see aerosols with cambic horizons, but it's much more common to find with argillic or natric horizons, okay? So, for example, in this photo, in this specific photo, we have an aerosol with a natric horizon, okay? So you can see in the picture, it's quite easy to see that this surface horizon has a sandy texture. You can see in the photo, and here seems something like quite heavy. So this texture of the image is showing you that you have a very high clay content, and here a very low clay content. So we have a difference of clay content, and this salt precipitation, it's showing you that you have a very high content of sodium. So this is a natric horizon, and in the natric horizon, you have, okay, just a second, guys. Can I take it? Yes, of course, of course. We can talk later. Sorry. Sorry, guys. Sorry, guys. Just someone arrived. So, as I said, we have here the natric horizon because of all of these conditions that I mentioned. Okay, we have a very strong wind and runoff erosions, okay, that decrease the clay content at the surface. We also have some salt concentration that also could induce some clay movement, some clay vertical movement, and increase the clay content at the subsurface horizon, okay? And this huge difference of clay content between surface and subsurface horizons induce the formation of a natric horizon. At the surface, in this case, we have a nocric horizon. So a nocric horizon, above an metric horizon. And because of the aeridic conditions, we have the aridisol. Okay? So the aridisols, they are soils connected to a specific climate condition. Okay, so we have a soil that can be found only in some specific regions because of the climate conditions. It's quite common to other soil profiles because the oxysols, for example, they are also straight connected to climate conditions because they are straight connected to intense or deep wafting and leaching. So it's just the same, but in the case of the oxysols, we don't have specific soil moisture conditions that we need to follow, okay? So basically, it's not something quite special. They are in the other orders too, but now in the case of the aridisols, you need to consider that information, okay? Let's talk about the autosols now. And the autosols, they also express a high clay content with depth. So they register a subsurface horizon, a diagnostic horizon at the subsurface that register a higher clay content than the surface. So in the case of the autosols, because of an intense clay removal at the surface, you decrease the clay content at a pattern or at the topsoil, and you create a huge or at least a high difference of clay content between the surface and subsurface horizons. So in this specific case, you register a high variation of clay content according to depth. And this also affects a lot of other soil properties, as I mentioned. For example, the velocity of the water migrating through the horizons and the soil. At the surface, the water can have a very high conductivity, but when this water achieves the subsurface horizons, this water cannot penetrate very easily. So the conductivity of the water at subsurface is much less or much lower than the surface horizon. Okay. In the case of the autosols, we also have something that's quite interesting, is that the saturation, the base saturation, it's low, indicating that this soil also registers a low natural fertility, chemical fertility. So the content of bases is quite low, and the soil it's more acidic. So it's more related to deeply wafted and leached soils. The wafting and leaching was quite intense and removed a lot of bases and increased the content of aluminum and hydrogen. So the content of elements that are connected to acidity or they can be potential toxicity, they are much higher than the nutrients, okay? So this autosol, the name came from Uti, came from the last soils that can be formed. It's not 100% true, but makes sense when you consider that they are formed by soils with a very low base saturation and register this increase of clay content at subsurface, because this process to reduce the content of clay at the surface, at the pattern, this takes time, okay? You need time, you need some centuries and even some millenniums to reduce the clay content at the surface or at least at tropical and wet tropical conditions, okay? And I'm saying that this is wet tropical conditions because you register low base saturation. To register low base saturation, you need a lot of chemical wafting and leaching. So let's think that now you register a dense vegetation cover. So a dense vegetation cover can protect the surface against erosion. So to remove clay in these conditions is quite difficult. It's quite hard, okay? Because you have a dense vegetation cover that protects the aggregates, protects the pads against erosion, against, for example, the raindrops, against runoff, and the wind erosion, so it's quite difficult in wet tropical conditions to reduce the clay content at the surface. And it's why I'm saying that takes time to do that, and takes time to reduce the clay content, and takes time to reduce the base saturation results. So you need time, you need a long time to create this kind of O2 salts. You can create a parallel with the oxysols. Both soils register or they need a long time to be formed. But in the case of the O2 soils, the difference is that they register a higher clay content at depth, at the subsurface horizons. This is not quite common in the case of the oxysols. The oxysols you can register in some cases, but it's not the most common case that you register a higher clay content at the subsurface horizons. Okay, so the main difference between oxysols and O2sols is considering the subsurface horizons. Okay, in the case of the oxysols, it's more correct to say that the clay content varies, but the variance is quite low. In the case of O2sols, it's more common to say that in this case, in their case, the variance of clay content is quite high. Okay, but both present an intense and deep wafting and leaching. Okay. So let's see the required characteristics to identify or to classify a soil as an O2 soil. You should register on argillic or candic horizons. And now let's just remember the difference between them. An argillic horizon registers some evidence, some features that express clay migration, clay vertical migration from the apaton, from the soil surface, from the topsoil to the subsurface. Okay, so we have some lessivage, some migration from the surface to the subsurface, some argillic, some alluviation that we call this kind of migration between the surface and subsurface horizons, and create some clay skins, those features that express a shiny faces on the aggregates, at the surface of the aggregates, okay, expressing this movement, this clay movement. And in the case of the candic horizon, we don't have this. We just have the higher clay content at the subsurface horizon when I compare the subsurface horizon with any overlying horizons. So both argillic and candic horizons both register a higher clay content at subsurface than the surface horizons, or at least the overlying horizons. But the argillic horizon register shiny faces, any feature that express clay migration. In the candic horizon case, no, I don't register this kind of features. Okay, so the O2 soil register an argillic or candic horizon, but no fragipan, and a base saturation of less than 35% at one of the following depths. So we need to consider that this base saturation will be less than 35% in one of these specific depths. Okay, so an argillic or candic horizon, low base saturation, no fragipan. Oh, JJ, I cannot remember what is fragipan. Fragipan, it's that horizon that's partially cemented by silica. Okay, it's more connected to dry conditions, not to wet, tropical wet conditions. So let's consider that to identify a O2 soil, I cannot register this fragipan. So now let's see the base saturation and these horizons at one specific depth. If the apaton has a texture class of coarse sand, sand, fine sand, loam coarse sand, loamy sand, or loam fine sand, so a sandy or loamy texture in the fine earth fraction through, then the base saturation criterion is met at either 125 centimeters below the upper boundary of the argillic horizon, but not deeper than 200 centimeters below the mineral soil surface, or 180 centimeters below the mineral soil surface, whichever is deeper. So I need to find at these specific depths, 125 centimeters below or 180 centimeters below the soil surface. One of these specific depths, I need to find low base saturations, okay? We consider this very high depths just to avoid that at the surface you have any increase of base saturations because of anthropic influence, okay? The humans, they can increase the base saturation, especially at the surface, trying to produce any kind of food, and because of this, we just consider very, very high depths or very huge values of depths to ignore or to avoid this kind of possible human influence on the base saturation, okay? Or at a densic, lithic, porolithic, or petroferric contact if shallower, okay? So if you register any kind of these horizons, the base saturation should be low, equal or less than 35% at the contact of any of these horizons. And the other option is that the shallow of one of the following depths, 125 centimeters below the upper boundary of the argillic or candic horizon, or 180 centimeters below the mineral soil surface, or at a densic, lithic, porolithic, or petroferric contact. Okay, these depths, they are for the other soils that doesn't register a sandy or loamy sandy textures. Okay, so basically we consider these values for the majority of soils. So, oh, this specific soil has a clay texture or a silty texture. Okay, so, okay, you need to follow one of these depths to consider the low base saturation. As I said, again, we use these values just as a way to avoid human influence, because it's quite common that humans increase the base saturation at the surface, but they don't do that at 100 centimeters below or close to 200 centimeters below, because they don't they don't want to expend so much money increasing the soil fertility at very low depth. Okay, so if you find until 180 centimeters below the mineral soil surface, very low base saturation, and an argillic or a candic horizon, yes, you can classify that soil as a no-to-soil. A fragipan and both of the following, okay? Either an argillic or a candic horizons above. So if you find a fragipan, you should mention an argillic or a candic horizons above the fragipan, and they should occur or below this fragipan or clay films that has 1 millimeters or more of thickness in one or more of the subhorizons. So in this case, you need to consider that you register clay films or argillic or candic horizons above the fragipan, and a base saturation that by the sum of cations, of course, it's what we do, of less than 35% at the shallowest of the following depths: 70 centimeters, 200 centimeters, or at a densic, lithic, porolithic, or petroferric contact. So in this case, the values are just different, but the concept, the definition is basically the same. If you don't register the fragipan, you need to follow those values: 180 centimeters or 125 centimeters. But if you register the fragipan, above the fragipan, you must identify an argillic or candic horizons, and you should consider that this low base saturation should fit one of these depths. So you need to find a low base saturation in the first 75 centimeters or 200 centimeters, okay, or at this specific horizons that express a low buffering, a low leaching, okay? So the ultrasoils, they are soils with low base saturation and a very high clay content at the subsurface. Okay, so let's see now the opposite. let's see soils that in this case present a very high base saturation. The case is the molly soils. The molly soils, they are soils that are straight connected to the molic apaton, though that apaton which registers a very high organic carbon content, dark colors, very dark colors, and high base saturation. Because these soils, they are connected to one or two specific parent materials, basically or mainly calcium carbonates. So the majority of molysols, they are formed by wafting of carbonates, and these carbonates could produce a soil, could produce some horizons that express very high base saturation, in some cases also very high organic carbon content, dark colors, and some specific process that express also concentration and precipitation of secondary calcium carbonate, magnesium carbonate, and other carbonates too. Okay. So I already show you the pictures of some molysols. You can see here, in this case, the molic apaton with this very dark color of the thick and dark horizon with a high organic carbon content, some cases very high organic carbon content, okay, and also very high base saturation, okay. In this case, you also can see the same. The thickness of the molic apaton achieves 40 centimeters in this case. So you have a very thick molic apaton, okay, and a soil, some surface horizons that also express calcium carbonate precipitation in some cases, or at least some fragments of rocks, and some specific properties that express a low chemical wafting, a low leaching, okay? It's the opposite of the autosols. And so what are the required characteristics to identify a molysol? First of all, you cannot classify that soil as one of the previous orders. And what we need to find, first of all, a molic apaton, or both a surface horizon that meets all the requirements for a molic apaton except the thickness after the soil has been mixed to a depth of 18 centimeters, okay? So in some cases, the molic apaton could be a little thinner than the required characteristics. For example, I should register a molic apaton with 25 centimeters, and it register a little thinner than that, just 20 centimeters. Okay, if you fulfill, if you meet all the required characteristics for a molic apaton except the thickness, maybe you can fit. If you fit this and a subhorizon more than 7.5 centimeters of thickness within the upper part of an argillic, candic, or natric horizons that meets the color, organic carbon content, base saturation, and structure requirements of a molic apaton, but it's separated from the surface horizon by an albic horizon. So, wow, it's a lot of information, right? Let's translate this in an easier way. If you find a horizon that fits all the criteria, color, organic carbon, base saturation, structure of a molic apaton, except the thickness, and below the molic apaton, you have an albic horizon. That is that horizon with very whitish colors, very strong whitish colors, okay, that express clay migration. And below this albic horizon, you have an argillic, candic, or natric horizons, okay? So you need now a molic, actually a horizon that it's not a molic horizon because you don't have the minimum thickness, but all the other properties, it's okay. And below this possible molic horizon, you have an albic horizon, and below the albic horizon, you have an argillic, candic, or natric horizons. So if you fit this and a base saturation of 50% or more in all horizons. So all horizons at the surface and subsurface horizons, they should be quite high. You cannot register a low base saturation, or at least should not be lower than 50%, okay, 50%. Why? Because I'm saying that this soil register a very high base saturation, a very high chemical fertility, natural chemical fertility. This specific soil register a very low wefring. So this specific soil cannot register a low base saturation. Okay, so it's why I said that it's a little of opposite of the O2 soil, because the wefring it's not intense. Okay, and in this case, I register so a molic apetalum or something that register a lot of criteria that could fit the molic apetalum, and below of it we have an albic, and below the albic we have an argillic, candic, or natric, and all of these horizons present a very high base saturation, at least 50% or more. Okay, and between the upper boundary of any argillic, candic, or natric horizons and a depth of 125 centimeters below the boundary, so you need to fall to fit this high base saturation, or between the mineral soil surface and a depth of 180 centimeters, or between the mineral soil surface and a densic, lithic, or paralithic contact, whichever depth is shallowest. So you need to find high base saturation between the surface and one of these horizons at a depth of 125 centimeters, or between the soil surface and the depth of 180 centimeters, or between the soil surface and one of these horizons. Okay, so you need to find high base saturations, guys. You cannot find low base saturations to identify a soil as a molly soil. Okay, and if you have a salic horizon, if you have a horizon that express salt concentration, in this case the saturation with water in one or more layers within 100 centimeters of the soil surface for one month or more during a normal year. So you need to have saturation by water in one specific horizon in the first 100 centimeters for 1 month or more, and a moisture control section that's dry in some or all parts at some time during normal years. So some part of the soil should be dry, okay, but some part should be saturated in at least 1 month. And you should not register sulfuric horizon in the first 150 centimeters below the surface. Okay, why we consider this sulfuric horizon? Because this horizon it reduces the chemical fertility of the soil. Okay, so this specific horizon it's quite problematic, reducing the chemical fertility because of very intense chemical wafering and production of acid, and increasing the content of possible toxic elements. So just to memorize the molysols. The molysols, they are connected to the molic apetalum. So the easiest case is find a molic apetalum with something below it, or I found something that fits all the criteria of the molic apetalum except the thickness, and below of it I found an albic horizon, and below of this albic horizon I find an argillic, candic, or natric horizons, and for all these conditions I found very high base saturations, okay, at least 50%. Okay, in this case, yes, you can find a molysol. If you register eventually a salic horizon, you need to consider this saturation and dry conditions in these cases, and you cannot find a sulfuric horizon. Okay, just if you find the salic horizon with the molic horizon in these specific cases. Let's see now another soil that's not deeply affected by wefring, is not deeply affected by leaching, that is the alpha sols, but in this case, the alpha sols, they didn't register the moleic pattern. So the alpha soils, they are soils that also register a high base saturation, they register a high chemical fertility, but is not so high like the moly soils. So they register less, or at least a lower chemical fertility, because they don't register the moleic pattern. You should remember that I mentioned it, that the moleic pattern, it's really, really good for pasture, for agriculture, for producing any kind of fiber or food that you can imagine. Also quite important to the native vegetation, because some species only can grow, especially the vegetable species, only can grow, vegetation species, they only can grow in above moleic pattern. But if you don't have this moleic pattern, you still can have, in some cases, a soil with a very high base saturation. But now the surface horizon, it's not so good as the moleic pattern. Okay, you register, for example, a high base saturation, but the color is not too dark, and the content of the organic carbon is not too high. So this is a soil that has, let's say, a regular condition. It's not a top soil. It's not a net pattern with very good or very high chemical fertility. Okay. So it's quite common to find alpha soils in dry lands because of the chemical warfare, so is not so intense, and you also doesn't have a very high addition of organic carbon at the surface. So you cannot register a moleic pattern, but you register at surface and subsurface very high base saturations. So it's quite common to find them in some arid and some semi-arid conditions. It's quite common to find alpha soils in the same regions that sometimes you can find the arid soils. Okay, but of course the arid soils will be found in the driest regions, and the alpha soils in, let's say, less dry conditions. Okay. And you can see here two pictures of alpha soils, soils with a pattern, in general an ochreic pattern or an anthropic pattern, but basically an ochreic pattern. So an pattern that the organic carbon content is not very high. The thickness of that pattern is not quite high. So we have a thin horizon with dark color, but not too dark, and a very average or low organic carbon content. And below this pattern, you register high base saturation, you register high CEC, high activity clays, because of the incipient or low warping and leaching of these horizons and the soil, as you can see. In all of these cases, you can see some horizons that could be classified, especially as natric and argillic horizons. Okay, in this case, you can see a natric horizon with a higher clay content. So you have here the apaton and here the subsurface horizon with this huge and beautiful prismatic structures. And these structures express a higher sodium content and a higher clay content at the subsurface than the surface, because of the salt formation, and the salt formation induced the clay dispersion and the clay migration from the surface to subsurface horizons, and increase the clay content at the subsurface. And because of this, you register a natric horizon, a higher clay content and a very high CEC, a very high electric conductivity, and a very high content of sodium. Okay, this is quite common to find in alpha salts. But also in this case, I register an argillic horizon. So I can find here an ochreic pattern, dark colors, but not too dark, low organic carbon content. You can see a lot of gravels here, and below this ochreic pattern, you can register an argillic horizon. This argillic horizon express some features that show the clay migration. So in this case, again, I register a subsurface horizon with a higher clay content than the apaton. And this higher clay content, in this case, is connected to a clay migration from the surface to subsurface horizons, okay? Oh, the soils also express office soils. You can see in this picture very, very easily the sandier texture than here. So this sandy texture express a low content of clay. Here you can see a very high content of clay, and this difference of clay content express that the surface suffer a lot of runoff, a lot of wind erosion. You can see that the vegetation cover seems like a dry forest. So the vegetation cover is not quite dense, it's open. You have a lot of soil exposed to the surface, and because of this, you have a lot of erosion and intense erosion and a intense clay removal in the surface horizon, creating this difference of clay content between the horizons. And you register, in this case, also a high CEC, high activity clays, okay? It's quite common to find in the alpha soils not only the prismatic structure, but also the columnar structure in this case, because this structure express clay migration, as I already mentioned. In the case of the netric horizon, it's quite common to find a columnar structure, and this structure express clay migration because the clay migration creates like a hat on the top of the prismatic structure. You can see here by the cracks that this showed in the original condition a prismatic structure with this yellowish color, and this zone that's lighter or has a white color seems like a coating, a hat and a coating covering partially a prismatic or original prismatic structure, creating this convex top that now it's called columnar structure, okay? So this also expressed this clay migration, and now because of the low wefting, low leaching, we have a netric horizon with very high CEC, very high activity clays, and a high clay content. I cannot call it as an autosol because we have a very high base saturation. I cannot call it as a molysol because I cannot find a pattern with very dark colors with a very high organic carbon content. Definitely it's not a molic pattern, so I will call it as alpha sol, okay? So you can see very easily here sandier texture at the surface and at subsurface, especially here. It's quite easy to see a higher clay content, and because of the low wafting, the low leaching, you have a high base saturation, okay? So you can think about the high base saturations, or you can think about a higher clay content at the subsurface in some options: molysols, ultrasols, and alphasols. And it's quite easy to distinguish then. The ultrasols, they should register low base saturation. Alpha sols and molysols, they should register high base saturation. So I can distinguish them. And now let's distinguish the molysols and alpha sols. The molysols, they should register the molic apadon or something at the surface that looks like a molic apadon, but didn't fit the thickness, only the thickness, but the rest, it's 100% okay. So in the molysols, I should register something similar or the molic apadon. In the case of the alpha sols, no, I cannot register low base saturations, and I cannot register a molic apadon or something that's similar of this molic apadon, okay? So let's see with the required characteristics to identify an alpha sol. Again, it not fit the criteria for the other orders, and I cannot register a plugin, a pattern that it's a pattern produced by humans by an intense mass movement and an intense addition of sand. You remember the plugin a pattern, it's an anthropic a pattern produced by humans, but in this case, the humans, they bring some materials trying to increase the soil fertility. And some of these materials, they could be rich in sand. So this difference of clay content between the app pattern and the subsurface should not be something that was produced by humans, should be something natural, produced by the nature. Okay, so in the case of the offisols, I cannot find the plugin app pattern, but what I need to find an argillic horizon, that is that horizon that register high base saturation and some features that express clay migration. A candic horizon, that's a horizon that express a higher clay content, but it didn't register the clay films, it didn't register the features that express clay migration, so just a higher clay content. Or the natric horizon, a horizon with a higher clay content, and the columnar or prismatic structures that were created by the high content of salts and especially sodium. Or I should register a fragipan that has clay films with 1 millimeters or more thick in some part of this fragipan. So I need to register a layer that it's partially cemented by silica, and this specifically horizon express some clay films, okay, some lamellae that express the clay migration in the past, okay. So you see that the offsols, they are basically quite simple. What I need to find horizons that express this clay migration, or at least a higher clay content, and it should register a high base saturation. Why this high base saturation is not written here, JJ? Because we already know that the O2 sols should register a low base saturation. So if you are if you are classifying, if you are describing a soil with a low base saturation, that's 35% or less than this soil should be classified as an O2 sol. If you register a high base saturation, or at least higher than 35%, so you should classify it as an alpha sol. So we don't need to mention here that the base saturation should be equal or higher than 35%, because you need to consider that if the base saturation is equal or less than that, the soil should be classified as an O2 sol. Okay, so this is something that I like in the soil taxonomy. They avoid to repeat information that's not necessarily, because they don't need to mention that all alpha sols should register a base saturation equal or higher, actually a higher than 35%, because all the soils with base saturation that equal or less than 35% should be classified as an O2 sol, okay? It's why we always says here in the beginning that to classify this soil as, for example, an alpha sol, this specific soil that you are standing, that you are describing, it should not follow the required characteristic for the others orders. Okay, so it should not fulfill the characteristics for the others soils. Okay, so it's the first step to classify a soil, and it's why we always need to follow those or that order, those characteristics, because if you just skip the list, if you skip the order, you can just see, oh, the off soils, they don't mention anything about the base saturation. So, okay, I can classify this soil as an alpha soil, but then you realize that it registered a low base saturation. So if you follow that order, this specific soil should be classified as a no-to-soil, not as an alpha soil, okay? So again, please, guys, always try to follow that order, that list, because this is quite important, okay? Now let's see the insectisols. The insectisols, they will be formed everywhere, but basically in areas that the erosion is quite intense. And because of intense erosion, you cannot create soils with a deep or a complex process. So you basically will find cambic horizons and others that express an incipient wafting and leaching, but especially simple process that are not more complex than pad formation, that aggregate formation. Okay, so you have a soil with some horizons or layers, but you don't register any complex or difficult process to identify than just aggregate or pad formation, okay? The insectisols, they are quite common in steepy slopes, as you can see in this picture, but they are also quite common in areas with dry conditions and formed by rocks that can be hardly wafted. Okay, so for example, let's say that we are describing a soil formed by quartzites. Quartzites, they are rocks that hardly can be easily wafted, and sometimes they form steepy slopes. So because of this, the erosion is quite intense, and in some conditions you can form in some insectisols. But they are also quite common in some areas formed by wafting of granites, because also if you have a steepy slope and low wafting and low leaching, but you register a B horizon, you can register a horizon with some pads and aggregates, yes, you can call it as an insectisol, okay? You already saw this picture. In this case, we have an ocrec app pattern at the surface that doesn't register a strong color, a strong dark color. The content of organic carbon is not high. The thickness is not high. And below of it, we have a horizon with a yellowish color. It's a B horizon. And this B horizon also doesn't register a large, thick. And basically what we see here in this B horizon is just structure. It's just pads and aggregates. We don't see anything else, just aggregates being formed. We don't see any increase of clay content. We don't see any kind of feature that express clay migration. We don't see any kind of secondary carbonate precipitation. We don't see any kind of salt precipitation. We don't see any kind of columnar or prismatic structures because of the clay migration. We don't see any kind of residual oxic concentration, like, oh, because of intense wafting of kaolinite and other minerals, we have now only gibbsite, goethite, and hematite. No, you cannot see that. Okay, you cannot see any other process that express an intense and deep wafting and leaching, and also hardly you will find a thick B horizon. They are most commonly very, very thin, actually, because the wafting, the leaching, and the soil formation is not quite intense. Okay. So let's see the required characteristics to identify an insectisol. First of all, you need to consider that the insectisols, they are soils that are classified in the majority of the cases because the other soils also cannot be classified. So we are close to the end of the list. Okay, and because of this, you need to consider always all the others soils, all the other orders before consider that soil that you are standing, that you are describing in the field could be an insecticide. First of all, you need to check all of the other soils to check. Oh, this could be an jelly soil. This could be an histosol. This could be an a spodosol. This could be an andisol, an oxysol, and blah blah blah. All the other options before consider an insecticide. Okay, and that insecticide, they don't have a positive water potential, so it's not fluided for more than 21 hours each day in all years, and they have a cambic horizon in the first 100 centimeters below the soil surface, and it has a lower boundary at a depth of 25 centimeters or more below the mineral soil surface. So I need to find in the first 100 centimeters a cambic horizon, and this lower boundary should be at 25 centimeters or even more than that. So it should not be very close to the surface, okay? Or I should register a calcic, petrocalcic, gypsic, petrogypsic, or a plastic horizon, or a duripan in the first 100 centimeters below the soil surface. So I can find other horizons too. Or I can find a fragipan or a noxic, sombric, or spodic horizons in the first 200 centimeters. But JJ, how can I find a noxic horizon and this soil is not an oxysol? Because let's say, for example, that this oxic horizon, it's below the maximum depth to identify an oxysol. So you should remember, for example, that to be an oxysol, you should register an oxic horizon in the first 150 centimeters below the surface. So if you find an oxic horizon, but in a deep higher than 150 centimeters, but less than 200 centimeters, so this could be an insectisol, okay? Because in this case, the oxysol, or not the oxysol, I'm sorry, the oxic horizon, it's deeper than the maximum depth to identify an oxysol. It's why I'm saying always that you need to follow the list. Okay, you need to follow that specific list that defines the order of the soil classification. Okay, so sometimes you can find some horizons, for example, an spodic horizon, and this spodic horizon you can think, okay, this could be an spodosol, but because of the depth of this spodic horizon, the depth could not fit the criteria for a spodosol. So because of this, is not an spodosol, and then could be an insectisol if fits the criteria to identify an insectisol. Okay, so you need to consider this, guys. You need to consider that even registering some horizons, if the depth of this horizon is too high for classify a soil as an oxysol, spodosol, or any others, so maybe the soil could be an insectisol. Okay, if I register a sulfuric horizon in the first 150 centimeters below the soil surface, so this could be an insectisol. And as I mentioned, the sulfuric horizon is that horizon that register a very low pH and or a potential intense production of acidity, because you have some sulfur in the soil, especially some pyrite, some minerals that can be easily wafted and produce a very high content of acidity and decrease the pH of the soil. Okay, or I register a soil with a cryotic or gelic soil temperature regimes, very low, very low temperatures, but I don't register, for example, the permafrost in the first 100 centimeters, or I cannot register some gelic materials that are evidence of cryoturbation and the permafrost in the first 200 centimeters. So I just register low temperatures, but without permafrost, okay, and a cambic horizon. So I have a cambic horizon that was formed in an area with very low temperatures, but no permafrost. This could be an inceptisol. It's why I'm saying always that it's more like exceptions. The inceptisols, they are more like exceptions to the regular cryosol, to the regular jelly-sol, I'm sorry, to the regular oxysoil, to the regular spotosol. They are exceptions for the main characteristics of the other orders. And if there's no sulfidic material in the first 50 centimeters below the soil surface, and in one or more horizons between 20 and 50 centimeters below the mineral soil surface, below the soil surface, either an N value of 0.7 or less, or a fluid class of non-fluid. So that material between 20 and 50 centimeters has a solid behavior, all or less than 8% of clay content, okay? And one or more of the following: a pholistic, histic, molic, Pelagian, or umbric pattern. So in this case, even if I found this kind of horizons, but they don't fit, for example, the characteristics for a histosol. So I have a pholistic pattern, but I don't have the minimum thickness to identify a histosol. So, okay, could be an inceptisol, okay? Or a static horizon, or in 50% or more of the layers between the surface and a depth of 50 centimeters, the exchangeable sodium percentage, it's 15% or more, or a sodium adsorption ratio, it's 30% or more, which decrease with the increasing of depth below 50 centimeters, and also groundwater in the first 100 centimeters below the soil surface at some time during the year when the soil is not frozen in any part. So if I register any high content of sodium, I should register also the groundwater in the first 100 centimeters. Okay, you can see that all of these criteria, they are exceptions for the other soils. Okay, they are exceptions for alphisols, histosols, jelly soils, and others. Okay. And we have the exception of the exceptions. We have the antisols. The antisols is the last order, the last option that you have in the list. So after try to classify a soil in all the options, if you cannot classify a soil in any options, so okay, this soil will be an antisol. The antisols, they are soils that does not fulfill the criteria for the other soils, for the other options. So you only need to think, or you only should think about the antisols as a last option after consider all possible options between the jellysols, histosols, andisols, spotosols, oxysols, ultisols, alphisols, blah, 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 all the 11 options, even the inceptisols. So even if the soil that you are standing is not an inceptisol, so then you see, okay, let's see, maybe, and not actually not maybe, but this is an antisol. Okay, if you do, if you did everything correctly, this is antisol. Okay, so the antisols, they are basically formed by a very, very incipient weathering and leaching and soil formation. They are much more common in very steep conditions where the parent material does not allow an intense soil formation. And because of this, we don't have even some B horizons formation. So you don't register a cambic horizon, you don't register any of those horizons that we mentioned, and like, for example, the petrocalcic horizon. So you don't register even the cementation of a layer by calcium carbonate. Even the most simple process you cannot register, because the soil, it's very, very young, or at least the erosion is quite intense, and because of this you have a very incipient soil. Okay, so you can see this kind of soils. Maybe they could be very, very thin, like this, 15 centimeters. And in this case, for example, JJ, why this is not an arid soil? This is not an arid soil because even if the temperature could be very, very high and the soil could be very, very dry, I cannot find an argillic or natric horizons, because I just can find an epipetal. This is just an A horizon, and below of it, I have the R layer, the rock. So just a nocrack pattern above the rock. I don't register any complex process that create a soil with specific signature, like, for example, the arid soil. So this soil is formed in a very dry area. You can see the vegetation cover stems that I have here in a dry forest with the desert pavement. I have all the characteristics, for example, for an arid soil, but I don't register the characteristics for an arid soil, so I cannot classify it as an arid soil. And I follow all the options. In the end, what I have is the anti-soils, a soil with a nocrack pattern above the rock layer. Okay, but in some cases we also can see some soils that could be quite thick, like this example. In the right, you can see a soil formed by several layers of marine sediments. In this case, I just register the organization, the structure formed by the parent material. I don't have any complex process that increased or decreased the clay content, that produced new minerals. I don't have a lot of wafting or leaching. I don't have any salt concentration or precipitation. No, nothing. I don't have even structure format. So basically, I have a lot of layers of sediments that were deposited by the marine currents. So the effect of the sea induced the formation of a soil basically formed by sediments with very, very low stage of soil formation. So even in this case, with a very thick soil, I can register an anti-soil. Okay, a soil formed by sediments without any strong pedalization or formation of aggregates and any of the other process that could form a soil. And is the easiest soil to classify, because the required characteristics is just that they are other soils that cannot be classified in the previous options. So we have 11 options to classify a soil. If this specific soil cannot fit the characteristics for any of these soils, any of these options, so you should classify it as an anti-soil. And we don't have required characteristics for this, because yes, we are trying to embrace all the options. If you create any kind of characteristic here, you could be redundant. You could are saying the same thing that you already said in the other horizons. For example, oh, I cannot register an argillic horizon. I cannot register an oxic horizon. I cannot register a molic pedal. I cannot register this or that. You are just saying something that you already said. So it doesn't make sense. You just mentioned that anti-soils are soils that cannot be classified in any of the previous options, in the previous groups, in the previous orders. Okay, so we have 12 options. You just need to follow the list, trying to classify the soil according one of those options. Okay. And as you could mention that, as you could realize that, I'm sorry, as I mentioned that, the only option that the app pattern really matters, really it's important, is in the case of the moly sols. So the majority, the rest of the other options, you need to pay more attention for the subsurface horizons. Okay. So when you have a moly app pattern, you just need to, okay, probably this is a moly soil, but let's check first. Okay, let's check if this specific soil fits the characteristics, fits the criteria to be classified as, for example, a jelly soil, because I can register a jelly soil with a moly pattern. Yes, no problem. I can have a moly pattern and the permafrost. Okay, this is a very good and interesting soil to describe and to study, because it register very low temperatures and at the same time a horizon with a very high organic carbon content, dark colors. Maybe this molecular pattern was formed in the past. We need to study it. I would love to study this kind of soil because it's quite strange, but could be. Okay, so the only soil that the app pattern really matters is the moly soils, and the others, they are like optional, let's say in this way. Okay, they could occur, for example, in the case of the arid soils, you have the ochric, the anthropic. They help you to identify them, just as a tip to identify soils with very specific conditions. Okay, so guys, do you have any doubt about all options? I know that it's a lot of information, but at least for now, do you have any doubt? Let me return to here. Um, I can see if someone raised their hand. No? Is everything okay? Okay, Najib. Okay. So, guys, I will stop here because I know that's a lot of information. And I will share again a new exercise. And now, this exercise, I will ask you all to classify the app pattern, the subsurface horizon, and now the order. Okay, so you have everything that you need for it. I will just share morphological, physical, and chemical information, and you need to do this before our next meeting. Okay, because in the next meeting I will start the WRB system. Okay, so in the next meeting, in the next week, we will start to study the World Reference Base for Soil Resources. And for this, it's quite important that you all already saw everything about the soil taxonomy, and there is no doubt, okay, especially about the classification. I know that's a lot of information, and it's why I'm sharing some exercise so you can practice and you can do to be sure that everything is at least 80 or 90% okay. Okay, I will share this in the end of this day, and I will ask you to send me the answers before next Monday. For the people that attend the course in person, or at least they are in Brazil and they plan to attend the course in person, I will schedule a field trip in the next few weeks. I will try to do this in the next week, but I need to be sure that the department can schedule the bus. I already asked them. I just need to be sure that they already pay for everything. If it's 100% okay, I will just let you know by mail, and we can go to the field work. We will start with a little field work. Okay, let's just go to a site close to Viçosa, and then we spend like 4 hours in the field work, and then we can return. Probably on Wednesday, but I need to be sure that they schedule the bus and everything's correct. Please, Najid, open your microphone.
Okay, thank you, Professor, for the wonderful lecture. I just want to remind you that because I don't usually receive your email in recent time, so please maybe when you schedule the field trip, I should be able to receive the email so that I can be notified before the time.
Okay, okay. I know why you are not receiving my mail, because I'm using the name of people here. Let me just add this right now so I avoid to forget. Just a second. I just need to add here. So okay, let's see. Okay,
Thank you.
great. Oh, thank you very much.
Thank you,
Oh,
Prof. All right.
great. So now you receive the invitation for this, and will be much easier to contact you. Okay, okay. So great, guys. I will, as I said, I will share this activity in our drive. Please be sure to do this kind of exercise before next meeting. And of course, if you have any doubt, just let me know, okay? You just contact me and we can schedule any meeting and we can talk and find this. Of course, I will not answer the exercise for you, but if you just, oh, JJ, I have this and this and this options and I'm not be 100% sure which should be the right answer, and I can talk with you and we can find the answer together. But we can schedule this, okay? I'm here to help you to find the answer and to solve any doubt, okay? So before next meeting, I will let you know about our field work for the people that attend the course in person. And before our next meeting, I hope everyone has finished the exercises related to soil taxonomy, and then we can start WRB. Okay? So guys, I wish you a very good week. See you next meeting. Okay? Bye-bye. Oh, yes, Abdul. Yes, yes, Adam.
Right.
Mhm.
Sorry, sir. Sir, I want to know. I want more information